Hi, and welcome to this live demo about shrink wrapping underground tunnels to remove internal noise picked up during the laser scanning process. My name is Richard Baxter. I'm Head of Sales and Marketing at MachineWorks, which is the company that develops the Polygonica software libraries. As always, we're on LinkedIn. Please follow us. We're putting out lots of content on those channels, and you can also follow our YouTube channel, which is where this video will go. Okay, first of all, what's the problem here? Well, laser scanning is commonly used for surveying purposes in underground tunnels. For example, as you're removing material from the tunnel, you can do differences between successive scans to work out the rate of material removal. You can measure critical dimensions. You can check access conditions, clashes, collisions, that kind of stuff. But the problem is it's underground, so the scanner is inside the tunnel. The laser scanner is hitting not just the walls of the tunnel, but also anything that's inside the tunnel. So that could be mining equipment, mine carts, like the nice example on the right. It could be rails. It could be people and miners, like the slightly more questionable example on the bottom right. But basically, all those things that the scanner hits inside the tunnel are going to cause noise that's difficult to differentiate from the walls of the tunnel. And also it causes scanner occlusion, so it means that there's gaps and holes as well, so you don't necessarily get a complete coverage of the wall. So shrink wrapping, Polygonica shrink wrapping can help that. What it does is it takes, if you like, imagine a large balloon that's shrunk around the outside of the mesh that's been created from the point cloud. And as a consequence of doing this, very large holes get filled, and small holes as well. So the holes get filled, and perhaps more importantly, because it's shrink wrapping from the outside, all the internal data gets excluded. So it stops at the outside points and doesn't go further in. So on the left, you can see this is a tunnel we've constructed, a set of tunnels we've constructed based on some points that we created using a scanner, and I'll show you that at the end, how we did that at the end of the video. And then on the right is the shrink wrap, which is shown transparently, so that you can see in it, and you can see that it's clean inside. There is no sort of noise inside it. And this is actually an example of a cross-section through the actual original tunnel reconstructed scan and the shrink wrap. So on the left, you've got the grey polygons are the shrink wrap, and the brown polygons are the original scan. And you can see the inside the tunnel there's lots of kind of noise where the scanners hit some carts and things like that. You can also see sort of light blue areas where there are holes due to scanner occlusion, and those have been filled in by the shrink wrap. And then the actual curves of the two cross sections have been drawn. So the blue curve is a cross section through the shrink wrap, and the red curve is through the original tunnel. So you can see the red curve has gaps, whilst the blue curve is solid, or continuous, sorry. But you can also see that the blue curve is really very tightly coincident with the red curve. So this is done to a reasonably high accuracy. It's certainly high enough for a normal analysis of things on this scale. And then on the right hand picture, I've just turned off the display of the original shrink wrap, so you can of the original tunnel mesh, so you can see what the shrink wrap gives you. It gives you a clean inside internal surface there. So the overall workflow here is, scan the tunnels, which requires moving the scanner through the tunnels. Then you do the normal kind of filtering and sampling of point sets. You need to align the point sets. You need to merge the point sets. Polygonica can help you with all of this, or you can use your own software to do it. And then at the moment, the shrink wrap only works on polygon meshes, not on point clouds. So you need to create a polygon mesh from the points. And again, Polygonica can do that for you. And that's how we've created the meshes in this case. And then finally, shrink wrap the polygon mesh. Now, the shrink wrap function, PF Solid Create Shrink Wrap, it has quite a number of different options. You can configure it and control it in different ways. But I think the most important one in this case is a tolerance that's in effect, if the tolerance is tighter, then it means that the wrap is closer to the original. it's on average within that tolerance. So that's great. You get a more accurate result, but at the expense of creating more polygons. And anyone who's dealt with these mining, these meshes from mining tunnels knows that they're very, very big. You can also loosen the tolerance, and I'm going to do that in the live demo with a slightly looser tolerance, and then you'll get a wrap that's further from the original, although potentially still, quite usable. And you'll get fewer polygons. So, with a looser tolerance, you can do a kind of interactive workflow. With a tighter tolerance, you might want to have more of a batch workflow where, you set the thing running and you come back in 10 minutes, half an hour, that sort of thing, and you've got a very tight, accurate wrap. Okay, so let's on to the live demo. Okay, so what we're looking at here is Polygonica demo, which is a demonstration user interface that we've built internally to demonstrate the Polygonica libraries. So it's not available as an end user application. You can't go and buy it anywhere. It is literally just a demo program. And so what I've loaded in is this faked data of some mining tunnels that have been scanned and then a mesh made from them. And it's faked because although we work with companies and we've worked with companies on this project, they won't let us use their data publicly because it's their customers' data. So we've created some fake data that looks reasonably like what they get. Obviously, typical scans can be a lot bigger than this, a lot more polygons. Okay, and you can see these green edges, these green highlights are open edges, so it's basically where there's gaps in the data. So I'm just going to go straight onto the Shrinkwrap because it takes a minute or so, so I'm going to set that going. So you can see Shrinkwrap has lots of options. I'm going to choose outside wrap in this case, and I'm going to set the maximum error to 0.1. I'll talk about these in a second. I'm just going to get it going. I'm going to go allow tunnels in the wrap, cap tunnels in the solid, and set a minimum diameter of about 10, and I'll just click that and get it going. So it's now doing the wrap, and you can see there's a progress bar on the bottom right. So let me explain some of these options. So this example, the dimensions, if you look over on the right here, are like about 119 by 202 by 17. So the tunnels themselves are probably like about 10 meters across, something like that. The height is 17 because it's on a slope. It's been created randomly, and it's randomly been created on a slope. So the tolerance 0.1, I guess, represents about 10 centimeters. So it's, if you're talking a large scale scan, it's still a reasonable tolerance. Allow tunnels in the wrap means that the wrap isn't going to join these areas here, these big regions between the tunnels. It won't cover them over. And then this minimum diameter parameter is the minimum diameter for what it considers to be a tunnel that it should allow, and a tunnel that it's going to cap the end of. So I've set that to be about 10 meters, which is what I'm guessing the sort of diameter of the tunnels actually is. So that's now done that, and you can see, okay, we've now got a closed solid. All the green edges have gone. If you look down at the traffic lights down the bottom, it's now closed, no self-intersections, it's manifold. It took about 52 seconds, and then we ran self-intersection fixing afterwards. So it took about 54 seconds. So we're talking a sort of interactive workflow here. I think if you're doing it for real data, you probably have more of a batch workflow possibly. And then if I make it transparent again, you can see there's no nasties inside that. It's clean. So what I'm going to do now is load in the actual original wrap as a tool. So I'm going to load them side by side, and then we can actually look at a cross section through them. So that's loaded. Can't see it. I'll just hide the main wrap, and then you can see that's the original. I'll show all. Okay, so now we'll do some cutting planes. So so this is just an OpenGL clip plane. Let me just change the orientation. So make it, there. And let's move it out. I think there's some internal data around here, so let me just spin that around. There we go. Oops, let's look at it that way up. I think just seem to have a kind of a base. And yeah, okay, so I'm just going to turn on, we're not rendering backface edges here, so let's just turn those on so you can see properly. And yeah, I'm having some problems with the graphics because I've got another larger example loaded, but you can see here, let me turn on the draw line. So if I zoom in first of all and look at how far apart they are, well, I said the tolerance was about 10 centimeters, and that sort of seems probably about right. The red line is the original scan, and the blue line is the shrink wrap. And then you can see that we've got this internal data, which is the stuff, one of the things we're trying to get rid of. So let me just hide that, and now we can see there is the actual clean wrap. So we've got a nice clean inside to that. So really that's what we're looking for. Now let me kill that one, I think, and then just do the same thing with a wrap that's been done to 1 centimeter tolerance, which you can immediately see. I set a limit of this of 5 million polygons, although I don't think it's quite reached the limit. So I'm going to do the same thing, load in the tool. I'll load in the original wrap as the tool. Has that done that? Yeah, that's done that. You can see the brown thing there, and then let's try, and I don't think I'm going to get the same profile, so let me zoom out while I do the section plane. Yeah, it takes a bit of time to set that up, and there we go. I must add a better way of positioning section planes to this at some point. But there we go. I think, was it that one, or was it a bit further on? No, it's that one. Here we go. There it is. Yeah. So there's some of the internal data. You can see it there. And again, I will turn on rendering both edges. So you can see it takes a little bit of time. I mean, Polygonica comes with a graphics engine, but it's far from optimized. Most of our customers actually use their own graphics engine, which would probably have faster updates than this. Okay, so there's, you can see, like we saw before, there's the internals. Let me put the section lines on. This time, if I zoom in, you can see the blue line is very close to the red line. So what we've got here is a pretty accurate wrap, and you can also see why the red line stops. We've the shrink wrap has actually closed the gaps. So if I hide that, you can see that there's a gap that's been closed there, and we've got a nice tunnel. It's all clear inside. I'll just for the final thing just hide that one, and actually no, it's not going to work. Show all of them and hide the wrap itself, and then you can see that they're like, for example, here this is where the scanner was, so it hasn't scanned above itself particularly well. Again, this is our faked scanner. Hopefully a real world scanner operator would do a better job than that. But again, if I show all and hide the wrap, sorry, hide the original, you can see that that's been nicely closed. Okay, so I think that's the general principle. If you're interested in learning more, just get in touch. There's a contact form on the web page. Just for curiosity's sake, I'm now going to go and show you how we actually created this data, because it just highlights some other functionality within Polygonica. Okay, so here we are in Visual Studio, and I'm going to run the mine tunnel wrapping example, which is what we use to generate this data in order to show you the wrap. So it's a little console project. I'll just make it a bit bigger, I guess. Maybe let's make that a bit smaller, and then it says press a key to create tunnel map. So first of all, it creates a sort of random shape based on a random seed of tunnels and stuff. And then it adds some noise based on a fractal noise algorithm. So it just tries to make that look like a real tunnel. And that's done that. And it's also added, so if I zoom in here, it's tried to make the tunnel look like a real a real underground tunnel. And we've added the mine carts and the strange guys with crossbows that you obviously find underground in mines that I showed in the presentation earlier. So those are the things that are going to cause scanner occlusion and also internal noise. So those are the things we're going to get rid of. So I'm double clicking again, and it's going to simulate a LiDAR scan. So we've actually created a virtual scanner, and that's being moved along the tunnel, creating different point sets. So in effect, it's doing array casting, intersecting with the tunnel and generating the points as a real scanner would, and it suffers scanner occlusion just as a real scanner would. It can run in parallel, but in order to show you how we've done it, I'm just running it in serial. So I'm probably going to pause this in a second and just cut towards the end like they do on Blue Peter, if anyone's familiar with that British TV show. Okay, so it's now faked that LiDAR scan. So we've got a nice bunch of point sets that we can align. Well, they're actually probably pretty well aligned, to be honest. But from that, we can triangulate them. So Polygonica is now using its point cloud triangulation algorithms to create a polygon mesh from it. The Shrinkwrap can be adapted to actually shrink wrap from point clouds directly rather than from polygons. We've just not done it yet. So if that's something that's really dear to you, then feel free to get in touch and we can talk about it. Now, I'm not sure quite how long this takes. Again, I might just shorten the video, or I might not. It depends. Oh no, I hadn't set it going. Now it's going. Oh dear. So I'm guessing this might take 30 seconds to a minute, is my guess. I mean, it's a reasonable size point cloud. Oh, okay, even quicker than that, 14 seconds. Okay, so now what we've got now is we've hidden the points, and this is the actual faked underground scan that we then used for the shrink wrap process in the previous video. So yeah, possibly a bit unfortunate we have to do this for our demos, but we'll be creating quite a lot more demos based on this fake laser scanning process, just so we can show some of the cool things that Polygonica can do. So yeah, watch this space. Thanks as always for your time and for listening. And if you want to get in touch with us, please do so via the contact form on the website.